Well, good afternoon. This is the final session. I'm very sorry about the slight delay, but yeah, we're good to go on the final session with the folks from from David and his team from Model9. One thing I need to say to you is if you've got any questions, please put it in the chat box and we will try and address them straight away. If need be, I will actually open it up for you to speak if there are any questions. The session is known as 3BG. So that's for the end when we need you to do the feedback, and I'll come on to that. But in the interest of time, I'm going to hand it over to David from Model9. Thank you very, very much.
Great. Thank you very much. Welcome, everyone. I'm David from Model9. With me is Ofer Baruch from Model9 as well, and Ashley and John, our colleagues and partners from AWS, who will be presenting the session today with us. And as the title suggests, our focus today is how Model9 and AWS can enable you to leverage the critical data you have today on your mainframe infrastructure, put it in the cloud, and leverage cloud-based scalable analytics to gain better and more accurate insights from that data, primary data and archival data. Now it is 2020, and we can't kind of really do a session without talking about COVID-19. So first of all, to all our friends and colleagues and partners out there, especially if you're in the UK and you're heading into your second lockdown, good luck, stay safe, be healthy. We'll get past this. And from a market perspective, digital transformation, cloud migration, modernization have certainly been big themes over the last few years, but the need to be able to deploy your resources in a flexible way, to scale your business up or down as needed based on rapid changes in the market, and the need to be more agile in the way you use your data has only been strengthened and expressed better through the needs around COVID-19. We see this in the market, we see this from our partners, we see this from the conversations we're having with customers, and we believe this trend will only increase as the nature of 2020 and 2021 is mostly about uncertainty and the need to do more with less on faster timelines and being more agile. Now, when it comes to moving your core mission critical applications to a modern infrastructure to the cloud, it's generally hard. If this is your core system of record or transaction processing system, to get it right on architecture, on performance SLAs, on cost management as you move to the cloud has proven to be challenging over the past few years for those core high performance data intensive applications. Actually, when it comes to mainframe applications, it's even harder, right? Because mainframe is a walled garden. It's hard to connect it to the cloud. You virtually can't do any lift and shift to kind of accelerate your transition. Data formats, data structures, and data management simply isn't compatible to what is happening in the cloud. But at the same time that it's extremely challenging to do so, a recent research paper from Gartner expects that the need to actually move to the cloud will drive over a third of mainframe data from existing infrastructure, from mainframe data from existing infrastructure into the cloud in the next 5 years. And this is a trend that's starting now and really accelerating over the next few years as organizations out there are looking for ways to push forward with their cloud migration, cloud adoption strategies, and include mainframe in that story. Now, if we take a look at let's call it the high-level journey many customers, many organizations have as they move to the cloud, it usually starts off from the desire to modernize and leverage modern scalable data management solution for their mainframe data. Once that has happened, there is a need and desire to leverage that data for better insights, to do BI on it, leverage machine learning, do archive mining, and expose that precious data that sits at the heart of the organization through modern scalable analytics platforms, such as the ones available on AWS, to the rest of the organization to improve the organization performance. And ultimately, since data has gravity, once the data has already moved from the mainframe to the cloud, you can then start by making much more conscious decisions about what workloads you want to peel off and start potentially moving to a more modern infrastructure now that the data is already available out there. Now, the challenge has always been that traditional approaches that usually fell under the category of ETL, extract, transform, and load, put a very heavy load and toll on the mainframe side. The need to literally pick and choose which pieces of data and information you want to move over. The need to expend high levels of resources from a CPU and time and people perspective on the mainframe side to continuously maintain the needed transformation and continuously decide which data needs to make it out there into the cloud are very challenging to scale. And they are somewhat even contradictory to how usually business analysts and BI operations usually work, where they need to iterate on their research. We believe that a different approach can deliver substantially better results, where we just move the data wholesale from the mainframe out into the cloud, out into S3, and then make it available on the cloud without burdening the mainframe resources, make it available from the cloud directly into downstream analytics applications. And the ability to engage with that data on a very quick cycle without going back to the mainframe substantially changes the way business analysts and data scientists can interact with the organizational data, be it the primary data or the archive data. One of the joint customers for AWS and Model9 is a large transportation company out of the US, where they were building a very big data lake on AWS, and they wanted to integrate and make the mainframe data available within that data lake for analytics. Their challenge was that they were leveraging traditional ETL tools to do so, and they were only able to push about 1% of their data out into AWS. With the implementation of this joint solution, they were able to move 100% of their data on a continuous basis into that AWS-based data lake, and are now able to gain quicker, more accurate, and more scalable insights into their operation because of that broad-based access to all their data, and the fact that they don't need to keep going back to their mainframe infrastructure to choose exactly what they want to access. I don't know if we have any questions from the crowd just yet, but if we do, this is a good point to ask them before we dive deep a bit more into the technology.
A very quiet audience, Eyal. There's been no questions. If there were, I would have interrupted, but no questions. So please, anybody, if you would like to ask questions, if you don't want to type it out, just put your finger on, or just put your hand, put a emoji, and I will open you up. So I'll give it a minute or so. I suggest we carry on.
It's fine. It's a tough hour. End of the day. It's okay. I'll hand it over to Ofer to talk a bit about how we do how the technology works and how the solution provides this option. And go ahead, Ofer.
Thanks, Eyal, and how everyone. So I'm going to take the next few slides to explain a little bit how we do what Eyal just mentioned. How are we able to move vast amounts of data in a scalable manner to AWS without consuming resources on the mainframe? So first of all, from a scalability point of view, once you define in Model9 what you want to move, when you want to move it, and how exactly, there are a few stages in that process. The first process is actually our discovery process. This process runs on one of your mainframes, one of the LPARs, and is capable of reaching out and looking for all the dataset patterns, volume patterns, storage groups that you have defined, or maybe even tape data sets that you want to move to AWS. Once the discovery starts running and finding resources which are eligible to be moved to the cloud or copied to the cloud, a backup process starts to run on all the available hardwares you have. So all of that's running in parallel. Every one of your LPARs is going to run multiple backups or copies to AWS in parallel in order to be able to move a lot of data and use all of the mainframe resources you might have. So this allows us to scale in different directions, both horizontally and vertically. So if you add more resource to your LPAR, whether it's zip engines, memory, OSA cards, that will allow us to scale. And also if you add more CACs and more LPARs, that will also allow you to scale. So I see there's a question.
Yes, I was just going to interrupt. There is a question, yes. Thank you.
So you're asking, if data is encrypted, how are the key transfers to AWS? So if you're mentioning pervasive encryption, then first of all, the keys are not transferred to AWS, all right? You will need to unencrypt that data on the mainframe, encrypt it again in flight, and it will then be encrypted on AWS at rest again. So if this is data you want to move in order for transformation, the keys are not moving away from the mainframe in a pervasive encryption environment. That's the mainframe keys and they will stay there. I hope that answered your question. So the next slide is actually a zoom in into one of the LPARs. So each one of the LPARs is running a Model9 agent. That agent is running multiple copies to the cloud in order to be able to get as much as throughput possible from your DASD system. So we are reading multiple data sets at once, but we're also sending multiple streams to object storage, splitting them up by default to 5 megabyte chunks, which allows us to avoid problems like high latency that sometimes happens in the cloud, and also push massive amounts of data in parallel, getting all the throughput you can get from your OSA cards and internet or maybe AWS direct connection. Now the next slide, I'm going to zoom even deeper. So let's look at a single copy from Model9, from DASD to the cloud. So even a single copy, what it does is it reads as fast as possible from your DASD system, but it doesn't send it in a single stream to AWS. So even a single data set is being chunked up to multiple streams and that are being sent in parallel to AWS. So this really mitigates the problems of latency and allows even a single data set to get high throughputs and move that data as fast as possible to AWS. Now, as I mentioned before, this is actually low-level track information. So this will actually move the data as fast as possible, consuming as little resources on the mainframe as possible. And all of this is zip eligible. So we also compress the data and encrypt it before we send it to AWS. So both from security perspective and utilizing your throughput to AWS as best as possible, and store that data on AWS with a minimal footprint as possible as well. So I see there's no questions. Let's continue. This is a diagram that shows the different components working with AWS and Model9. On the left, you can see two different sites. One is the primary site with an active mainframe, and another one as a passive in the DR site. Both of them has access to AWS. There's no hardware that needs to be installed on premise. So the mainframe is working directly with AWS and nothing else is needed in between. As I mentioned, in an encrypted and compressed manner from both disk and tape. So the Model9 is writing directly to Amazon S3 storage. And with AWS lifecycle policies, you can also move data, call data, those long archives into Amazon S3 Glacier, which will reduce the storage cost as well on AWS. We also have our management server running on AWS, which is another Docker container. This is the component which will provide you the web UI, the ability to define your policies, what you want to move, how you want to move it, and when in an easy manner in a modern UI. The last component is the Model9 transformation service. And it's important to understand this service is running on AWS itself. So when this service is engaged, it actually takes the low-level data information you just placed on AWS and transform it into open systems format, let's say like a CSV or a JSON file, or maybe it's a simple text file, but it'll do that in UTF format and will allow you to consume that data with any of the AWS analytics, BI, or machine learning services, which we'll hear about in a few minutes. So Eyal, if you move to the next slide.
Any questions to offer? Okay, now circling back, so thank you, Ofer, for the technical information. Now, circling back to how is this reflected in things customers are doing with this technology? So we just wanted to share a few high-level use cases that we've been working with our customers, and focus specifically on the benefit that customers are seeing from consolidating their mainframe-based data and their external data into one data lake, one data repository available for a single framework for analytics. Since most customers that use mainframe also have more recent applications, for instance, think about a bank that has a wide variety of modern digital products, but they also want to cross-correlate and run analytics on the user behavior on those digital projects versus what is actually happening on the transaction logs and the bank transaction logs that are being kept on the mainframe. Once that data is sitting on a single data lake, a single repository, they can do that. The ability to leverage modern medical treatment systems and diagnosis system and use deep learning of historical medical records over the last 10, 15, 20 years to assess new treatments, to diagnose patients, and to recommend the right course of treatment for every condition, can create substantial value and improve healthcare capabilities while providing for patients. When we're talking to the emergence of massive data points coming from IoT sensors, for instance, on a factory floor or an autonomous vehicle fleet, the ability to cross-correlate that with the operational data that is kept in the systems of record and the transactional systems on the mainframe can allow for substantially better utilization and efficiency in managing workflows, in managing operational efficiency, and in ongoing optimization to the organizational processes. And similar to what we talked about earlier with the customer example, the ability to correlate the operation of the transportation services that they services that they provide with the actual data coming back from the vehicle fleet is significant and can improve the operational efficiency for the organization. Unless there are any questions, I will hand it over now to John and Ashley to focus on what happens once the data is on AWS and what are the different options and tools that can be leveraged by organizations to analyze the data. I will just mention that at the tail end of the conversation, we'll hand it back over to Ofer, and he will show you a live demo of how this happens end to end in a very simple, easy to implement way, and of taking data all the way from the mainframe into AWS, into Quicksite that we'll talk about just now, and immediately start gaining value and insights from the data.
I do see we have another technical question, Eyal.
Yeah, go ahead.
So I'll just read it. When a data set is to be sent to AWS using ADRD-SSU as a data mover, does ADRD-SSU create a temporary dump data set? If so, do you delete the temporary data set at the end of the transfer process? So the answer for that is very simple. When we use DFDSS in the background under our address space, there is no temporary dump created. We actually take those data tracks directly to AWS, and there's nothing that needs to be deleted at the end. Everything happens in memory and does not require any data set. I can see there's another question. Thank you. Yeah, I think this one will be for you. What is the difference between Model9 and IBM's cloud transfer connector software?
Okay, so that kind of takes me back to somewhat to the conversation about ETL versus ELT is what we do. We're looking not at only propagating continuously propagating changes from the primary data onto the cloud. There's a portion of the data that can get pushed out to the cloud. What we are focused on is moving the entire data management operation to S3 object storage, both primary and archive data. So we take over the entire data management, moving all the data out into the cloud, primary and archive data, and then without compromising the operation of the existing applications on the mainframe, and also make it available through transformation to downstream analytics. So while IBM Cloud Transfer is focused on kind of continuously propagating changes, we're focusing on moving the entire data management to a cloud-based stack for better performance, better, easier scalability and flexibility, and better cost. I hope that answers the question.
Let's assume the question's answered and then move on.
Sounds good. Yeah. So thanks, Eyal. Thanks, Ofer. So yeah, now I just want to kind of talk to you about how some of our customers are implementing big data and analytics workloads that can meet different use cases. So Ofer and Eyal kind of went through some of the challenges that mainframe data can present, and then the process of kind of migrating that data and persisting it within S3 or something for long-term storage. So I'll kind of spend a bit of time kind of talking around the value of data lakes, some of the tools that you can use within the analytics ecosystem, and then I'll pass on to Jonathan, who can talk to you about how to implement self-service BI with something like Quicksite. So just to kind of set some context here, so we're constantly hearing from our customers that they want to extract more value from their data, but often they struggle to capture, store, and analyze all of the data that's being generated by today's digital businesses. So obviously, as I'm sure we can all appreciate, data is growing exponentially. It's coming in from new sources. So you might have mainframe data being ingested. You might also have data coming in from applications, from IoT devices, from internal systems. And as a result of all of this, it's increasingly diverse, and it's always in kind of different structures and formats. So you might have structured data, semi-structured data, unstructured data, and also have a requirement to maybe ingest some of that data in more of a real-time fashion, as well as on an incremental fashion as well. And as a result of all of this data, it's increasingly being used by many different people. So whether it's data scientists, data engineers, analysts, or developers, and it's also increasingly used by many different applications as well. And as a result of this, you kind of need an end-to-end platform that can ingest, store, analyze, and report on that data. So here on the slide, you can see the tools that are available within the AWS ecosystem to do just that. As I just touched on, I see that this really encompasses a few main areas. So firstly, you need to ingest the data. You then need a methodology to have a long-term storage for that data. You then have different methodologies in terms of applying the analytics against that data. And then once you've got the data ingested, stored, and analyzed, you then need a way that you can report on that data. So within the AWS ecosystem, we offer a whole plethora of different tools in order to do that. So just touching on the bottom layer, the blue box, that's where you look at data ingestion. So from a real-time perspective, we offer tools like Kinesis, or our recently announced managed stream for Kafka offering for real-time data ingestion. We also offer tools for batch ingestion, where maybe you want to extract, transform, and load that data. For that, we offer a tool like Glue, which can also help in terms of providing a data catalog. And then once you've kind of got this data ingested, whether that be real time or on an incremental basis, you then need a way to begin to store that data. And typically we see that customers are using S3 in terms of doing that. So Ale and Offer kind of went through the Model9 use case and solution where they're ingesting the mainframe data and then they were persisting that within S3. So we typically see that customers are using that as their data lake. So it looks like the slides gone. I'm not sure if that's the same for everyone else. There you go. It's back now. There we go.
All right.
So yeah, the middle layer kind of talks around how you begin to, sorry, just back one slide. You know, how you begin to kind of store that data. Then when you look at the third box up, the orange layer, these are all the different tools you've got to meet your different use case from an analytics perspective. So whether that's kind of data warehousing, whether that's a big data approach, whether it's more of a serverless analytics approach that you want to take, we offer different tools in terms of doing that. So if it's kind of things like traditional data warehousing that you want to do, but you need that scalability with cloud, a lot of our customers are adopting a tool like Redshift. We also offer a tool called EMR for managed Hadoop and Spark workloads. AWS Glue I went through quickly, which, as I say, is an ETL tool that will also allow you to kind of catalog your data so it becomes searchable by all of your different users. Athena, that's a great tool as well, because that will allow you to apply SQL queries from the data directly within the data lake. So imagine you had data that's being ingested from the mainframes and from other sources. You could persist that data within S3 as your data lake and then just populate some analytics over the top of it. We also offer solutions for operational and search-based analytics with something like Elasticsearch, as well as Kinesis, which I touched on for real-time analytics. Once you've kind of got this data, you then need a way to visualize all of that data, which will lead on to Jonathan to cover that part and how you can do that with Quicksite. So this is a slide that just kind of touches on why we're seeing customers move to data lake architectures. Now, we've heard this term a few times already today, so I just want to set some context into what a data lake is and the value that it can really bring the value that it really brings for our customers. So you can kind of really think around a data lake as a central repository for all of your different data types. So whether that's structured or unstructured data, and allows you to store that at scale. So the whole concept is that you store the data in its native format, and then you apply the different analytical tools thereafter. Like I say, that could be from BI and dashboarding to big data processing, and also things like machine learning. So an example of this is you might store your data within S3 from the data that's coming in from your mainframes shown with the Model9 solution, but also maybe bring in other types of data within that data lake. So that could be things like log files, it could be clickstream data, it could be data from other different applications, maybe it's data from IoT devices, or maybe it's social media data. So you can kind of think about the data lake as that central repository for all of your different data that you want to ingest. A question that you might ask is, does this kind of replace a data warehouse? And I don't see that it really replaces or diminishes the value of data warehouses that you might have in place today. I see it more of as an evolution of the data warehouse. So you can have a repository for your data, but then also use the data warehouses in tandem for things like historical analysis, and then use the data lake for other solutions, like I say, be that clickstream data, be that data for machine learning purposes and things like that. The other thing that it will allow you to do is it really brings different roles within the organization to the data. So whether you're a data scientist, a developer, whether you're a data engineer or an analyst, it allows you to kind of access all of that data within S3 and then apply your different choice of analytical tools and frameworks in tandem with it. The other key element of it is, as I mentioned, kind of with the machine learning element, if you want to kind of get predictive insights using machine learning, you can kind of use this based off the data within S3, acting as your data lake to do things like, say, it's forecasting, predicting customer churn, to look to increase operational efficiencies, these sorts of use cases. These are the reasons why we're really seeing customers adopt this data lake architecture. And just to kind of finish on this, so we kind of see a few key reasons as to why we're seeing customers choose AWS as their data lake store, as well as for the analytics ecosystem as well. Looking at the first element, it's really because AWS has a really mature offering of analytics services. And like I say, this can range from a broad range of different use cases. So whether that's data lakes, whether it's big data processing, whether it's data warehouse modernization, real-time analytics, or self-service BI, we have that end-to-end platform that can kind of encompass all of this. So be that whether it's data from your mainframe data, along with all your different other types of data as well. Security is obviously a key ask for all of our customers, and obviously it's always job zero here at AWS for us. So we provide a secure infrastructure for all of these different analytics. So everything's kind of encrypted. You've got encrypted at rest and encryption in transit with certain technologies. You can set things like permissions and things like fine-grained access control. And the other thing to touch on is that we're also compliant with a lot of industry-specific and geo-specific regulations as well. Third point to touch on is that we offer an integrated stack. So a lot of these tools that I've kind of gone through have a direct integration, and as a result, it's a really mature set of analytics tools. The other point to touch on is that we often embrace open source and open data formats. So from an open source world, tools like Elasticsearch and Kafka, we fully support them, as well as supporting the open data formats as well. So with the Model9 solution, we're talking about having the data in, be it text files, be it CSV, be it JSON. You'll find that AWS fully support all of these open data formats, as well as a whole bunch of other things as well. Final top point to touch on is that we provide the best performance, we provide the most scalability, and also the lowest cost for analytics as well. And all of this is really inherent with the fact that it's cloud-based technology. So the whole idea is that you can utilize your tools on a consumption model, so you only ever pay for what you use, and then you have the inherent scalability of cloud, so you can kind of scale up, scale down. It'll also give you a lot more agility, because the time to release in terms of getting up and running with cloud technologies is really expedited, because the tools are already there. You just need to kind of spin them up within the console. So just to finish, so I've kind of talked you around different methodologies to ingest the data. We've kind of been through the different tools you can do in terms of applying the analytics against that data, using S3 as the data lake architecture. The final element we need to kind of touch on, which Jonathan will go over, and then we'll see a demo, is how you begin to visualize that data. So that allows me to introduce Jonathan, who can talk to you about how to do that with a tool like Quicksite.
Thank you very much, Ashley. Hello to you all. My name is Jonathan Preston. I'm the Business Development Manager for Amazon Quicksite in EMEA. And what I'll do today is I want to just briefly touch on the benefits of Quicksite and how this can visualize the data that you have in the mainframe. And obviously, you're going to see a demo of that through Offer today with Model9, and how you can leverage other data sources to visualize that data in other areas of your business. So with Quicksite, what we aim to do is we aim to sort of solve some of the more business outcomes that you have the main issues that you might want to solve with today. So a lot of customers we talk to, they have obviously data in the mainframe is very hard to release and understand what that is trying to bring out. But in terms of then blending that data and merging that data with different data sources, the business wants to understand, what is the customer doing? Is the customer happy? Is the customer not happy? Who are they going to be leaving? What is the customer 360 view? And they really want to identify any data points in the data which you can't really see with the human eye. So they're looking for next generation BI services to provide this type of insight, and this is what Quicksite can do. So Quicksite is essentially the first business intelligence service that was built in the cloud. So with this, it means that we don't have the traditional challenges that a lot of BI tools have by having, client server architecture. So this means that from a scalability, we can go from a small number of users to thousands of users overnight, scale up and scale down. We have a pay per session pricing model, which is very unique and allows you to only pay for what you use. You can start to create dashboards in minutes, and this really provides insights for anyone, for anybody in the business. You can be in line of business user, you can be a data scientist, you can be a developer. Anyone can create insights with Quicksite. We leverage all the security and controls that we have with the AWS security. So in terms of permissions, things like integrated access management, so row level and column level security is something that we provide out of the box with Quicksite. So this allows you to have full control of who can see what when you're visualizing that data. And then finally, we have a wide range of APIs that you can leverage to fully automate the visualization. So in terms of creating users, onboarding users, creating templates that you want to share with the business, creating those dashboards and those views, you can fully automate that process with Quicksite. So we can connect to, as I mentioned to you earlier, a variety of different data sources. This is a snapshot of some of the data sources that we can support today. So we support a lot of traditional on-premise data sources, obviously including mainframe, which is a very difficult data source to connect to. Then we have a lot of cloud data sources, such as our own, and plus other vendors such as Google Analytics is supported with Quicksite. And then we have applications that you can start to connect to and to pull data from, such as Salesforce and ServiceNow, and unstructured sources like Twitter. So how does it work? Essentially, once we talk to these and connect to these data sources, we bring them in, and connect to them. We start to build a data set. We start to build the analysis, and then we start to build those analysis, share those dashboards, and either take those dashboards and embed that into your application, or we can leave it in Quicksite for your end users and readers to consume. One of the main benefits of using Quicksite is that we have the added advantage of leveraging machine learning that's built into Quicksite. And this allows you to have many more benefits than using traditional tools. So one of the first major machine learning pieces we have is anomaly detection. And this is something that's switched on in the Quicksite service. It allows you to focus on a data set and really understand what are the outliners within that data set. What are the things that have happened in the data set that you can't see with a human eye? When did it happen? How did it happen? And you can start having all these different contributing facts around, what was the expectation of that detection? When did it happen? What was the pattern in the data set? Next, we have forecasting that's built into Quicksite. So we're using the random cut forest algorithm that's built in. And this allows us to predict different forecasts. For example, sales forecasts, you can look up to 180 seasons ahead, or you can look back over 6 months of data, and you can start to forecast where are you going to be in your sales, for example, in the next 1 year, 2 years, 3 years. With Quicksite, once you start building these charts and visuals, that's great, but what does it actually mean? What is the context about those charts? So Quicksite allows you to provide different narratives and build that around each chart that you build. So when you're building your visuals for the business, you can quite easily put that business logic in English around those visuals, so people in the business understand what these charts and trends you're trying to show. And last but not least, we have full integration with machine learning models. So for example, if you're using the AWS service SageMaker, you can plug in one of the SageMaker models, or you can connect to your own machine learning model that you've created to leverage more insights from Quicksite. So the end goal is for you to build interactive dashboards that you can share with the business. And these dashboards have all the controls that you would typically use. So things like drilling down, filtering, zooming in, easy access to understand what that data is, being able to export these reports and dashboards to CSV files, Excel, and to be able to access the data if you're on the road. So if you've got a sales team which are on the road and they want to, they want to access these reports, they can click into the Quicksite module, which allows you for mobile access, and they'll be able to view these reports wherever they are. So it's a very simple, easy way to visualizing your key business metric data in a simple way. One of the things we can also do is, once we've built those dashboards, we can embed these dashboards into your application. So here are two examples where we have two customers here. One is Zoomla, where they have their the advertising gaming ads, which have been visualized for the business, understand where these ads have come from, how many ads are there, and they're showing this in a heat map. And then at the bottom you see from our customer Sound of Data, who are based in the Netherlands, and what they're doing is they're visualizing with Quicksite the call center metrics that are created for their customers. So they have customers like Ticketmaster and Sonos, and they manage all the call centers for those companies, and they're able to understand and visualize, how many calls were coming to the call center, from which country, the duration, et cetera, et cetera. So they have a lot of different KPIs that can be created and used with Quicksite. And then finally, from a customer's perspective, Capital One, they have around 25,000 readers of Quicksite reports. And from a banking perspective, they are using Quicksite in several different line of businesses to perform different use cases. So you see here from fraud and anomaly detection all the way through to operational reporting, lots of different use cases. And one of the main reasons for using Quicksite is that they didn't want to have this server rehydration and downtime. They wanted everything to be up and ready. When they grow and they scale, the service needs to be available. They also didn't want to have any client software to be installed locally. They wanted everything to be in the cloud. From a software commitment side, they wanted to make sure that they only paid for what they actually use. So they were spending thousands and thousands of revenue using tools that were just literally license-based tools which they weren't using. So one of the main reasons for Quicksite is that they're able to save a lot of cost by using Quicksite and being able to visualize the data in a very simple way. Okay, so seeing is believing. So we're going to have a demonstration of Quicksite right now, where you'll be able to visualize and see the data from the mainframe into Quicksite. So I'll just hand this over to Ofer to show you this.
Thank you, John. So as Jen mentioned, I'm going to have with you a quick live demo where I'm going to take some DB2 image copies with bank transaction information. I'm going to send them to the cloud, to AWS, and we're going to transform them into a readable format. And I'm going to show you some Quicksite dashboard that I've quickly created. Now, while Model9 can move any type of data, sequential data set, VSAMs, COBOL application data, we chose to have a DB2 image copy. So just to put in perspective, I have here a few decades worth of image copies. The latest one is here as well. If I browse it, you can see this is a block level data from DB2, really not something anyone can make sense of easily. So what I have here is a job that's going to do the trick. I'm going to submit it because it's going to take a minute, and I'm going to go through it real quickly. The first step, what it actually does is send this data to AWS. So this data set, that image copy I just showed you, is going to send to AWS, and this step will end when that process ends. The second step is really not running on the mainframe. It's just a trigger on AWS to cause the data transformation to happen. So I can give this service a few parameters. For example, I want to compress the output that I'm going to create on AWS. I want to make it a CSV, and I want to make it a UTF-8 format. So there's other things like where I want to get it from what bucket I want to put it in AWS, and a lot of different things you can do. So you can see this job has ended already. So I'm going to jump on to Quicksite and show you something nice. So what I've been able to do is, in really a few minutes, as John and Ashley mentioned, is create a dashboard that uses this data that I just upload to AWS and create some insights from it. All this data is doing, this dashboard is doing, is pointing to that folder on AWS that I just placed my data. So you can see here a few visuals that shows both withdrawals and deposits from the different media types, whether it's credit cards, ATMs, checks, etc. And also a graph showing the balance across the different years. Now, the interesting thing here to see is that we're able to visualize decades worth of information very fast, very easily, and without doing anything special in order to do that. So we're able to move vast amounts of information, historical image copies from tape, VSAMs, COBOL datasets, wherever your data resides, move them to AWS very quickly, very efficiently, and then directly starting to utilize that data and get insights out of it. So this is the end of the demo. If there are any questions, feel free to ask. Oh, I see one already. Where is it? Here we go. No, no questions. Sorry, my bad.
So, any more questions, anybody, please? If not, I'm going to bring this to a close. But before I do, I've got to say, what an excellent team bringing this presentation together. It went very, very smoothly, and I'm very, very pleased about that. So thank you very much for an awesome presentation. I actually learned some insight myself, so brilliant. This is the last session for today. The Model 9 guys are going to be doing a presentation on Tuesday the 10th on the second session. It's about slashing mainframe data costs. So again, if this is the quality of your presentations, I'll definitely encourage people to go along to that session, and I'm going to be chairing it as well. We would like you to do feedback. That's very important, not only for these guys, but also for GSE. We actually thrive on the feedback, and it allows us to put presentations like this together. So I'd encourage you to do the feedback. To get the feedback, you can either do the QR code, or if you go into the agenda, you can actually basically tap on the description of the session, and up there at the bottom is the feedback form, and it fills in all your candidate information for you automatically. So please fill that in. If anybody's got any further questions, thinking, oh, you know what, I really should have asked that question, I'm going to pick on you, EL, because your email is also in there where you got the Zoom registration. So if you've got any questions, then point them at EL. Is that fair, EL?
That's great. Share any questions. We'll be happy to answer them.
So it leads me to say thank you very much, and whatever you guys are doing tonight, make sure it's a good one.